Hi, this is just a video that's going to cover the best IA that I had last year, and this one was marked very harshly. We gave it a 21 and we were really quite harsh. I think I could have easily have gone for a 24 because if you look at the exemplars that IB gives you, they're really quite terrible and they're really marked quite lightly, but in practice I think the IB examiners have their own quirks and have their own history of decades of teaching chemistry, and they really are a lot harsher, I think, in reality. So often you'll get stuff that's either kept the same or marked down. I've never had something marked down, but we mark really harshly. I've only been marked up, and that was once, and I've never heard of anyone being marked up. And so this was definitely marked really harshly. I think it's a 24. I gave it a 20, believe it or not. And then my colleague, we did internal moderation and we decided, we should give it at least a 21. And then it went to external moderation with IB and they kept it the same, unsurprisingly. So what I've done here is I've given it full marks for curiosity, input, creativity. I've marked it 1 down on exploration, and this tick sort of indicates that there, and so that's got safety there, and so I'll just have a look at those. I'll talk about that. You'll see the 5 written in the report coming up. Analysis of 5, you'll see that in a second. Full marks for evaluation, slightly down here on limitations. But not enough to put it to a 5, and then communication, the buffer calculations, so that was an easier one to knock it down 1. So I probably think it could have easily gone to a 23 then, because you could clearly knock it down, well, perhaps not for one of those. Alright, so it's a 21 out of 24. I think a very safe 21 out of 24, possibly higher and worth a bit more, but that's what we put it in for, and that's what it got. So an investigation of the buffer capacity analysis of phosphate and carbonate buffer system. Now the reason I think this student did so extremely well is because they're a biochemist. They're currently studying biochemistry at university right now, and they just jumped on this because this is really significant. Why is chemistry so important? If you can't do, if you're not very good at English, they say do physics. If you're really good at maths, we'll do physics. The opposite, if you're not good at maths and you're good at English, do biology. But if you want to be a scientist, then do chemistry. Alright, because this student is serious about biology, and if you're serious about biology, you have to know how to make buffers to keep things alive, cell cultures or animals or whatever. And so chemistry is essential for that, and she kind of understood that and jumped on the fact that you need buffers for biology. And she looked at the system here and she realized that humans have this. They've got actually 3 buffer systems. Another buffer system is the proteins, and it's really interesting here, and she's done her research that people just jump and use one buffer system, which makes sense because it's simple, and the conclusion of the results kind of confirms that as well. And so she's done a lot of research to see that why is there not much information about perhaps mimicking the blood systems and using a mixed buffer system. And so that was really interesting. The fact that she's gone for buffer capacity is really high level stuff as well, and it's also, this was the new syllabus where they took out buffer capacity out of the calculations, and it's in one of the options, and so they really love you to go above the actual syllabus when you're doing high level stuff. And so they like that sort of stretching you beyond the syllabus. So a lot of people have experiments that are questionable because they're too simple and they're not really IB level. And the way to get rid of that is just to take it to IB and take it that little step further. And used to be able to do that, things like the Nernst equation, but they put the Nernst equation into IB. And so buffer capacity is kind of one of those things. And then she's gone above and beyond that, and she's actually done osmolarity, which is fantastic. And so osmolarity is taking into account, you've got a thing full of chemicals, and she's taken into account, well, this is life, so you can't have, you can't have osmosis going on here. It can't be too salty or not salty enough. And then so she's really killed it on that, and that was really sort of what impressed me and kind of shocked everybody. And so it took me a while. Where has she done it? I did this in my uni days, osmolarity, and so I had to go back wherever she's done the osmolarity calculations here, and I had to spend a few hours to check that. So I doubt the examiner did, but you can trust me, I did do that. And we have a very good lab tech who goes beyond the effort he puts in is crazy, and he actually double checked these too, which is beyond what we need a lab techs to do. So he's really gone above and beyond as well. So thanks to Ace. And so those I've checked, and so she's checked the osmolarity, and then she's checked that that's what it should be, the blood osmolarity. All right, and so that's really just absolutely caning that PE. It'd be difficult to find an IA that really does it this well. That really does cover a lot of bases as well. Pun not intended. And so what we have here is a very good introduction. Covers all the information I want to know. Covers the research, so it's very well written, very well referenced. So she obviously started very early on this, early in H3. I get students to start thinking about the questions then, because that way they can do the research and they can base it on the research. So please refer to the video. I'll put it in the corner of how to get a research question, because this is a just never-ending question students have of how to get a research question. It's very, very easy. All right, you get research first and then you come up with your question. So you find something you're interested in, which is probably the most important thing, then do the research and then get your question based to further answer or get closer to the answer to your question based on what research has already been done. All right, that's the be and end all of every research question for all the sciences and everything else in IAs and EEs in IB. All right, that's how you do things. People just try to know what they try and do. They just try and find an easy way to do things like vitamin C or something, and just try and get some easy marks, but they're not actually doing real research and coming up with new information. So you have to do the research first to know what's been done first before you can come up with some new information. So do that. Moving on. So we're just getting to technicalities now of why this didn't get a perfect mark or possible weaknesses. My colleague, who was an experienced examiner, just refused to be marked down, so he's just always extremely harsh. And so this is nice, okay, nice increments, telling me exactly what it's done, telling me how it's done, telling me the accuracy, done them well with significant figures and uncertainties. This is a slight, that's a slight anomaly because she's been really good with her sig figs throughout the whole thing. And so in general, if there's a slight anomaly but in whole it's correct, IB won't mark you down. So that's all good. She's got all the finer points too, like she's got like the right writing out, and so you can see she's polished it up, and she's had a look at all of these things here. What's one of the weaknesses? She didn't actually mention the temperature of the room is not as critical. All right, does have an effect as the actual temperature of the solution, and which is why I hate diagrams. All right. Because you can pretty much lie in diagrams, or you don't know what's really going on. And so this is an actual issue that she didn't actually control the temperature in the solution because she didn't measure it. If you don't measure it, you don't have it controlled. All right, and so she should have had the temp probe, and maybe I missed that in the analysis of this. I don't know if she's covered it somewhere else. No, she hasn't. So maybe I could have marked it down for that. Maybe I missed that on the first run. And everyone else has missed it too. But that's sort of a minor, well, it's maybe not that much of a minor thing, because it is slow and it is running. The temperature would not have changed a great deal. And so another major thing here that's helped her get fantastic marks is using the data logger here. And so she could just let this run automatically, and this is a drop counter, so it measures the drops, and she calibrated it too, which is brilliant. Most students don't even, you tell them to calibrate, but it's just too much effort and they just kind of go with it. And so she calibrated this every single time, which was quite impressive. And so she knew that the volume that was dropped through. So using these data loggers is the only way that you can get decent data. So if you go down to appendix, look at that. There's no possible way you could do that using a traditional titration method. You have to automate it with data loggers to get that much information. And so thanks to the school for having decent equipment for that. And so when we have, so that's good. So this is, I've marked it, yeah, this is where she's got, she's got 9 there. That's not a fantastic reference, but you're allowed to do that if some systems allow you to just reference the whole page if it's too long, if you go to the individual page. So where's the safety here? So she hasn't told me what to do. Low hazard, but she actually hasn't told me to wear goggles and glasses. So as I said, that we're marking her down on just technicalities, any possible way that it could get possibly marked down. So I did take a mark off for the sig figs. That's really harsh. Okay, so we're really, really harsh, because that's almost nothing, and then she's done it properly when it counts. Although no, she hasn't done it on the graphs. Alright, so maybe that is legit. Alright, so the volume here is plus or minuses on here. And she hasn't done that on her graphs. If I just look at her data, where's her data table? Plus or minus 0.01, and so her graphs should be the same thing, and she hasn't done that, so that should have been 0.00, and this should have been plus or minus 0.01, and so that's a slight error. So that's rather minor as well, but we've taken a 1 down, so maybe that is legit. I would have liked more grid lines as well. That's been a little bit harsh as well, since this is a data log that's taking a lot more accurate data than you could possibly do with hand. We're measuring it with hand. You wouldn't do that, and so you can see that she's annotated it well. She's told that her definition of buffer capacity is a change in 1 pH, and so that change in 1 pH then correlates to this volume, and that's her buffer capacity analysis. And she's changed the ratios of buffer and phosphate accordingly and measured it all differently, and then she's analysed it well, and she's got qualitative observations, which is great. This is a concern, but she's done it, which is fantastic. So maybe the temperature was significant in this, because there's fizzing, so there is a bit of a reaction going on. She's managed to put it all in one table. IB seems to be tolerant of multiple tables, which doesn't show much understanding or processing. You're just throwing, I hate that, I really do. Alright, everything, one table. Alright, you really need to argue your case if you've got me as a teacher of why you need more than one table. I just want to have a look at the whole thing. Look at this. I can just see, look, okay, she's changed the phosphate to bicarbonate. I can see some significant stuff going on here. I can see the raw data, and then I can see, well, that's nice too, take the largest one. I can see the volume of pH here, so trial 1, 2, 3, the average. And so this one took a lot more, so the answer is quite clear just by looking at the table. Alright, and so that's a fantastic table, and it's got all the necessary parts, and then she's done a decent graph as well, showing that basically phosphate buffer just by itself is always better. Alright, and so that's brilliant. And IB seems to be very tolerant of lots of little errors in here and still give full marks, so I think this is one's pretty much close to perfect. I asked for error bars too, which has been removed from the syllabus, but I think that helps give you a really good understanding of the uncertainty of your method. So you just take the worst one and just use it for all of them. That's the standard procedure to do it. And so I went through and I checked these in the draft, so I didn't check it twice. I didn't like the setting out. You don't actually have to go to the Henderson-Hasselbalch equation. You can actually use the current IB syllabus and go from first principles. That's probably actually preferred, to be honest. I really don't like the derived way of doing things. This is pretty much a derived equation. I leave that to the abstract physicists. IB tends to go for that because I've seen it in the mark schemes, and that's how they do their multiple choice questions. They pretty much derive an equation and then ask you which one's correct, which is fine for multiple choice, but not good. I don't like it for just to lead someone through how that's worked out, what the understanding is. And so she's lost a mark there, which I think all of it's possibly harsh. She's found a reference value, so you never finished your IOs until you've given me an idea of the accuracy, an idea of the precision, which is uncertainty propagation. And so moving on, the discussion is fairly well done. She talks about the different issues, she tells me what the answer is, and then her evaluation. I think I marked it down 1 because the temperature, right? If it's going to be a living system, you should have controlled the temperature way more and kept it at a constant temperature. So it should have been incubated at 37 degrees, since we seem to have gone for blood here. And maybe we're going for cell cultures, but if you're doing for some sort of other animal, you would have had to have referenced what the temperature of that animal is, or the normal environment it enjoys. And so apart from that, she sort of analysed the errors fairly well. I think she was in a danger zone here. She told me, look, do I have to put it into a table? She wanted to keep it in this sort of paragraph form. I should have told her, I should have said no. Basically, it's too dangerous. All right, if you've got it in a table, like the template, I'll put another link at the top in the corner now. Follow this template and you'll get a good mark. But the table here will tell you if there's a blank missing. All right, so have you told me if it's systemic or random? Have you told me the effect on the actual experimental answer? Have you explained a solution? And so when you're in paragraph form, it's much harder to read it very carefully and tick all the boxes for each one and know how many errors there are. But when it's a table, both you and the examiner can see that everything's covered. So tables are the way to go. That's why the template has lots of tables. Best way to cover all your bases and make sure something's not forgotten. Alright, so apart from that, look at all these really good references here. Ooh, they're not alphabetical. Alright, this is an IA, not an extended essay, so the exemplars are nowhere near as good as this, and they get, some of them have full marks, or one does at least. So that is all very good. That's all brilliant. Alright, so hopefully that will help you see how to do a really good IA. There are videos I've also got, I'll put that in the top hand corner, how to do uncertainty propagation, and there are also videos covering a whole lot of other stuff if you go look in the playlists, and so that should hopefully help you know how to do a brilliant IA. So just as a conclusion, find something you're interested in. That's by far the most important thing. All right, you have to enjoy this. And number 2, do the research first. All right, and you might not get what you want done. Okay, you just have to extend what has been done. That's clearly what everyone needs to do, and people just are missing that somehow. And so you shouldn't really get questions on, is this a good research question? You should be able to tell what needs to happen next based on your research. You shouldn't need to ask anyone if that's a good research question or not. Okay, so best of luck.